Okay, I wanted to talk through a couple of the answers in problem set 1. And the first one is, they're both the ones I'm going to talk through are have to do with the demand for healthcare services. And so the first one, suppose that the price of a unit of medical care is 100, person's insurance policy covers up to $100,000 in expenditures incurred on behalf of the insured individual per year. Show graphically how the maximum payment limit affects the quantity demanded. Assume a zero copay up to the limit. So we have here, I need my pen. We have here our usual supply and demand framework. So quantity, we just have units, whether they're physician's office visits or something else. We haven't really specified. Of course, in the real world, the units might be lab tests, office visits, you name it. But we're just assuming homogeneity just to get the basic idea across. Price in dollars per unit. And we're given here that the cost per unit is constant at $100. So that's just the price charged. Now, what the individual pays, what the insurance pays, that depends on the nature of the coverage. And we know there's one more given piece of information and that is that the insurance policy covers up to $100,000 of payments on healthcare services per year. So there's going to be this threshold when we get to 1,000 units, we will have exhausted our insurance coverage, and then we're on the hook for everything out of our own pocket. All right, so actually my dental health plan works like that, by the way. So there are insurance policies that do that. The answer in the answer key is I don't think it's quite right, and I prefer you to think through the case when you see any problem like this. Think through, well, what would a healthy person situation look like? Depict that. What would a sick person's situation look like? Depict that. That's figure 3.3 in the text as it talks about different demand curves in the presence of a deductible. Gives you a model for that, as well as my answers in class. All right, let's think first of the demand by a healthy person. And there, $100,000 per year is an extraordinarily high amount of spending on healthcare, even in the United States. So we'll think about a healthy person that's going to demand much less than that. It doesn't matter where you draw this. Let me give you an idea what a relatively healthy person's demand is. My whole family of 5 uses about $4,200 of services per year. So we're way below 100,000, and most people are. The spending per person average in the United States is like $9,000 or $10,000 right now. Anyway, the point is, for a healthy person, that limit is irrelevant, and they're gonna. I misspoke. That's what talking and without thinking does to you. The healthy person has all of their health services covered. There's a zero co-insurance rate is another way to say that. So this would be the demand of the healthy person. And notice, because of the very generous insurance benefits, zero copay, the effective demand curve this person brings to market is DH prime. And that's because the person's just going to demand, or the household, however we want to think about it, is just going to demand any unit of healthcare services for which the marginal value is greater than zero. So there we go for the healthy person. Now, let's think about what the sick person looks like. And the sick person's demand, so sick that they use up their $100,000 per year of health coverage. So this is maybe a person on a ventilator all year or something like that. I'm not sure how you hit that. I know people do, but I haven't had any direct experience with that. So a really sick, I'm going to put very sick, it's really, really sick, the person that's going to use up all that $100,000 of benefit, everything after that comes out of the person's own pocket. So they're only going to use the amount of healthcare services that any unit of healthcare services that this type of a person or household is going to use is going to have to promise a value greater than the $100 per unit they're going to have to pay out of pocket. So we're going to put Q sub very sick as the quantity that very sick person that has burned through their 100,000 is going to use, and I forgot to label the healthy person uses Q sub H. So there you have that one. Let's go to the next one. Where there's a lot going on here. What's the difference between a stop loss and a deductible? Okay, in short, a deductible is the amount you have to pay out of pocket before you get any generous insurance benefits. So if I get a dent in my car and it's costs me $500 to fix it, well, I have a $2,000 deductible. I just pay that out of pocket. But if I wreck my car and it's totaled, let's say I have $10,000 worth of damage. Well, I have to pay $2,000 out of pocket, and then $8,000 more is covered by insurance. So that's a deductible. A stop loss is something different. And a stop loss, a lot of insurance policies that have some co-pays or co-insurance at normal usage rates, maybe there's a stop loss provision that, if the household's expenditure out of pocket exceeds $10,000 for an individual, then after that, there's everything else is covered. So that's a stop loss. So the insurance will pay everything over a certain amount after the person has exhausted a certain level of spending. That level would be defined as the stop loss level. All right, so the way you do these problems is to first assume that the person has no insurance coverage, and then think about the deductible and see how that relates to the person's usage. Look at figure 3.3 to see how that works. And then we'll talk about the stop loss toward the end of the problem. What you do is figure out what insurance applies, figure out what the household would use, and then just double check to make sure they didn't exhaust. They didn't hit the stop loss limit. If they hit the stop loss limit, things look a little different. All right, so let's move forward. We draw our supply and demand curves, and again, it's price per unit and units per year. Typically, I was going to say a calendar year. We have a situation in our health. The enrollment period's like now, late February to mid-March, and but I think it's a calendar year. The benefits are calculated on a calendar year. Anyway, everybody's policy is a little different. That's why administrative costs in the U.S. are so high, among all the other problems with healthcare in the U.S. All right, so P equals 30 minus Q, or Q equals 30 minus P. Those are both the same. The demand and the inverse demand and this kind of demand curve look pretty similar. So we've got a y-intercept at 30, an x-intercept at 30. That's the demand curve without any deductible or copay factored in. So let's, what else do we know? We know that we've got just $10 a unit of a constant price. And then let's think about how the deductible would work. There's a $100 deductible, so using 10 units of service would blow through our deductible. And of course, this person, if they pay the full $10 per visit, they demand more than 10. So they burn through their deductible. They're going to pay more than $100 on healthcare for sure. And then now past the deductible, so we will blow through our deductible. Past the deductible, there is insurance coverage, and there's a co-insurance rate of 50% or 0.5. And so past this point, we have some insurance. So Notice that the person's willingness to pay for that 10th unit, after that deductible is exhausted, the person's insurance plan would kick in. I haven't drawn this quite to scale. So we've got to figure out, how does the demand curve that the person presents in the marketplace look when there's this 50% coinsurance? And basically, we can start here. We'll get the endpoint here at 10 units of usage. The person will, the person's valuation of that 10th unit of healthcare services is 20. And so then you think, well, if there's 50% coinsurance, what market price would result in an out-of-pocket payment of 20? And of course, at 50%, if the price were 40, that person would end up having to pay 20. So we know that a point on the demand curve, now that insurance is kicked in, is going to be that blue point where the quantity is 10 and the marginal value is 40. The market price could be 40. The marginal valuation comes from the individual's valuation. That's 20, and that's the amount the person pays with the coinsurance. Well, we know that the point where the x-intercept is always on that shifted demand curve. So we've got 2 points on a straight line. So we'll call this D prime. That's the insurance demand the healthcare demand that the insured individual would bring to the doctor's office. And then you would ask, well, how much would they use? Notice that if they didn't have any insurance, they would use 20. And the question is, what is this demand curve? It turns out this point is 25. Let me show you how to calculate that. Basically, I know that the point 10, 40 is on that curve, and I can see that a rise of 40 and a run of 20 is the slope of that line. So slope is -2, and then I can use the general P equals MQ plus B format to figure out what's my y-intercept. So, and then I can figure out, when I have the equation of a line, I can figure out the quantity of that. So P was 40 equals, M is the slope, -2 times 10 plus B. So B is equal to 60, right? -2 times 10 is -20. Add 20 to both sides, I get B is equal to 60. So the expression for this new demand curve is P equals -Q, -2Q plus 60. Well, then when I go 10 equals -2Q plus 60, solve, and you get Q is equal to 25. Now, another way to do it, you know that the coinsurance at a price at 10, with 50% coinsurance, the person's out-of-pocket is 5, and you could just have plugged 5 into the original demand curve. That's probably easier. I did it the hard way. I do things the hard way. All right. So we know that we know this is what it looks as long as the person hasn't blown through their stop loss. We need to just check the person's paid $100 out of pocket, and they use 15 more. 15 times 5 is 75. So they're at 175. So they haven't hit their stop loss. Had they hit their stop loss, I'm just going to do this in yellow, there would have been remaining, the demand would have just followed the x-axis until whatever their $200 was, and then it would be just a vertical line at whatever level of usage. Basically, their demand curve would have been, had it been out to the right, let me get a pointer, don't want to mess this up. If their demand had been like this, we would have found that